Hello everyone. How are you? CCNA Module 2. Network Access. Let's start. Network Access 2.1 Configure and verify VLANs, normal range, spanning multiple switches. Access ports, data and voice. A data and voice access port is required when you have a computer connected to a VoIP phone at a desk. The switch port is configured with a voice VLAN and a data VLAN. This is called a multi-VLAN access port, MVAP. The VoIP phone has two different ports in the back and acts as a switch. The PC port is for the computer, and it uses the access VLAN configured on this switch port. The switch port on the back of the VoIP phone connects to the switch. The VoIP phone will use the voice VLAN configured on the switch B. Default VLAN. Keep in mind two facts about default configuration on Cisco switches. By default, all switch ports are in VLAN1, and on a trunk link VLAN1 is the native VLAN. So this means that a device connected to a default switch port on one switch could communicate at LAYER2 to a device somewhere else on your network which is also on VLAN1. Essentially, you have a broadcast domain which you have not explicitly designed. From a security perspective, we like networks which are explicitly defined, that way we know what traffic to expect. To a certain degree. To mitigate this problem, there are two fixes. The first is to place all unused switch ports in a VLAN other than one. Whatever this VLAN ID, it should not be trunked off the switch. Combine this with defining the native VLAN ID on your trunk links to a number other than one at both ends of the link. This ensures VLAN1 is actually tagged on the trunk link. Both of these steps help to break up and give visibility to the VLAN1 broadcast domain. And remember, VLAN1 is used by control traffic, so don't try blocking, just don't try mixing user traffic in with it. C. Connectivity. Connectivity encompasses all WAN protocols used to create networks for broadband access: ATM, frame relay, X25, ISDN, dial, PPP, and tunneling. In each of these areas, Cisco offers comprehensive protocol support that adheres to relevant standards. Cisco supplements this standards-based approach with a range of functionality in order to integrate Layer 2 WAN connectivity protocols with key network functionality, including integrated security options, integrated quality of service techniques, simplified configuration techniques, integrated IP support, and hardware support ranging from simple CPE devices to high-end aggregation platforms. This combination of elements allows Cisco customers to use the broadest array of connectivity options to meet their WAN needs and deliver superior network performance and value. 2.2 Configure and verify interswitch connectivity. 8. Trunk ports. A trunk is a point-to-point link between one or more Ethernet switch interfaces and another networking device such as a router or a switch. Ethernet trunks carry the traffic of multiple VLANs over a single link, and you can extend the VLANs across an entire network. 1. Enable 2. Configure terminal. 3. Interface. 4. Switch port mode. Dynamic auto desirable trunk. 5. Switch port access VLAN. VLANID. 6. Switch port trunk native VLAN. VLANID. 7. And 8. Show interfaces. Switch port. 9. Show interfaces. Trunk. 10. Copy running config. Startup config B 802.1Q. In order to form a trunk link with our switch, it is necessary to create one sub-interface for every VLAN configured on our switch. After creating the sub-interface, we assign an IP address to it and set the encapsulation type to 802.1Q along with the VLAN to which the sub-interface belongs. C. Native VLAN. It is a best practice to explicitly tag the native VLAN in order to prevent against crafted 802.1Q double-tagged packets from traversing VLANs. In many enterprise networks, VLANs are used to separate the network into logically separated networks. 2.3 Configure and verify Layer 2 discovery protocols. Cisco Discovery Protocol and LLDP. LLDP overview. LLDP is a protocol that enables network managers to troubleshoot and enhance network management in multi-vendor environments. LLDP standardizes methods for network devices to advertise themselves to other systems and to store discovered information. LLDP enables a device to advertise its identification, configuration, and capabilities to neighboring devices that then store the data in a management information base (MIB). The network management system models the topology of the network by querying these MIB databases. LLDP is a link layer protocol. By default, the device terminates and processes all incoming LLDP packets as required by the protocol. Cisco Discovery Protocol, CDP. Cisco Discovery Protocol is a Layer 2, media-independent, and network-independent protocol that networking applications use to learn about nearby, directly connected devices. Cisco Discovery Protocol is enabled by default. Each device configured for Cisco Discovery Protocol advertises at least one address at which the device can receive messages and sends periodic messages to the well-known multicast address 1:0 devices discover each other by listening at that address. They also listen to messages to learn when interfaces on other devices are up or go down. Advertisements contain time-to-live information, which indicates the length of time a receiving device should hold Cisco Discovery Protocol information before discarding it. Advertisements supported and configured in Cisco software are sent, by default, every 60 seconds on interfaces that support Subnetwork Access Protocol (SNAP) headers. Cisco devices never forward Cisco Discovery Protocol packets. Cisco devices that support Cisco Discovery Protocol store the information received in a table. Information in this table is refreshed every time an advertisement is received, and information about a device is discarded after 3 advertisements from that device are missed. The information contained in Cisco Discovery Protocol advertisements varies based on the type of device and the installed version of the operating system. Cisco iOS version running on Cisco devices. Hardware platform of devices. IP addresses of interfaces on devices. Locally connected devices. Advertising. Cisco Discovery Protocol interfaces active on Cisco devices, including encapsulation type, hostname, duplex setting, VLAN trunking protocol, VTP, domain native VLAN. Some of the information that Cisco Discovery Protocol can learn includes 2.4 Configure and verify, Layer 2, Layer 3, Ether channel, LACP, of LAYER2. Ether channel is seen as a single link by STP, allowing to use all the member links for better performance. Most of the times of LAYER2 Ether channel is configured as a trunk 802.1Q more often and can carry multiple VLANs broadcast domains. What is a Layer 3 Ether channel? A Layer 3 Ether channel is similar to an interface on a router. The switch won't switch traffic on this interface but route it. Because it's a Layer 3 interface, we configure an IP address on it. 2.5 Describe the need for and basic operations of rapid PVST spanning tree protocol and identify basic operations. PVST, per VLAN spanning tree plus, is a Cisco proprietary STP version. It is also the default STP version for Cisco devices. It is the standard named 802.1DA root port, root bridge, primary, secondary, and other port names. Root port. A root port is selected on all non-root bridge switches on a per-switch basis. Root ports are the switch ports closest to the root bridge, based on the overall cost to the root bridge. A root bridge is a reference point for all switches in a spanning tree topology. Across all connected switches a process of election occurs, and the bridge with the lowest bridge ID is elected as the root bridge. B port states, forwarding, blocking, learning state. At this moment the interface will process Ethernet frames by looking at the source MAC address to fill the MAC address table. Ethernet frames, however, are not forwarded to the destination. It takes 15 seconds to move to the next state called the forwarding state. If you just have command line access to your switches, jump on one of your switches and do show spanning tree there. That will tell you which is the root bridge. To find the entire topology and to see which ports are forwarding and which are blocking, you really just have to map it out switch by switch. C port fast benefits. The port fast feature is introduced to avoid network connectivity issues. These issues are caused by delays in STP-enabled ports moving from blocking state to forwarding state after transitioning from the listening and learning states. 2.6 Compare Cisco wireless architectures and AP modes. APs can be networked together in a variety of architectures. The size and scalability of the network determine which architecture is most suited for a given implementation. Autonomous AP architecture, cloud-based AP architecture, lightweight AP architectures, CAPWAP operation. 2.7 Describe physical infrastructure connections of WLA and components, AP, WLC, access trunk ports, and lag. What is WLC and AP? The wireless access point, AP, has lost the intelligent characteristic, while the wireless access controller turns into the new brain for WLAN. In the case of the wireless LAN network, also known as WLAN, you can use the WLC or wireless LAN controller, whose purpose is to centralize the control of access points, APs. What is access port and trunk port? What's Cisco access trunk ports and lag? These may also be referred to as trunk or access respectively. The purpose of a tagged or trunked port is to pass traffic for multiple VLANs, whereas an untagged or access port accepts traffic for only a single VLAN. Generally speaking, trunk ports will link switches, and access ports will link to end devices. 2.8 Describe AP and WLC management access connections, Telnet, SSH, HTTP, HTTPS, consoled, and TACAX radius. Telnet SSH Telnet and SSH access can be done on CLI by using WLC management interface IP address. On CLI, you should use SSH or Telnet keyword, and then you should use the management IP address. If the Telnet SSH service is on, and there is no restriction for Telnet SSH session, you can access the wireless device with this method. HTTP HTTPS to access GUI, graphical user interface, of the WLC, we can use HTTP and HTTPS. HTTP is insecure, and HTTP is secure way to connect. By default HTTP is disabled, but it can be enabled to use. And HTTPS is enabled by default. To access WLC GUI, we can use HTTP/HTTPS over a browser. Here, service port interface or the management interface is used to access GUI. To access GUI, 192.168.1.1 is the default IP address. Radius TACAX to access a wireless device. Radius or TACAX authentications can be used. For this access, user credentials, user passwords, are defined in a radius server or TACAX server, and before the access, user credentials are checked. If the correct credentials, user passwords, are given, then user access accepted. All users have special username and passwords, and these information is stored in a remote radius server or TACAX server. While accessing the Cisco WLC, the username and the password is requested from the user. If user write the correct information, he or she can access Cisco WLC. 2.9 Configure the components of a wireless LAN access for client connectivity using GUI only, such as WLAN creation, security settings, COS profiles, and advanced WLAN settings. The Cisco WLAN solution can control up to 512 WLANs for lightweight access points. Each WLAN has a separate WLAN ID, 1 through 512, a separate profile name, and a WLAN SSID. All controllers publish up to 16 WLANs to each connected access point, but you can create up to 512 WLANs and then selectively publish these WLANs using access point groups to different access points to better manage your wireless network. You can configure WLANs with different service set identifiers, SSIDs, or with the same SSID. An SSID identifies the specific wireless network that you want the controller to access.